I want to talk about something that you're going to be using called an LED. All right? And first that, so this is a, okay, so we're going to talk about, we're going to now talk about LEDs. It stands for light emitting diode. All right, let's first talk about what a diode is. So this is just a diode. Right? So up to now, we've been talking a lot about resistors, and therefore I relied on Ohm's law, right? And here we go. Now we have something else. So now you're going to be like, there you go, professor. You're not going to be able to go the whole class and teach us the entire sort of recipe of all medical instruments with us only needing one equation because it's Ohm's law, because now we have something that's something different, right? It's not a resistor. Not so fast, okay? Not so fast. Here's how a diode works, all right? When there is a positive voltage, so let me draw it in this, use this color, a positive voltage in this direction, all right? Then the diode acts, I'm going to say, like a resistor, all right, in this case, but it is a very low value. So it's almost like a wire. Okay, but still, a resistor is, right? A wire is like a resistor with a very low resistance. So maybe it's 0.01 ohm or 1 ohm. Now, when the voltage is applied the other way, so I could take a 9-volt battery and put it like this, right? Now I'm going to switch the 9-volt battery. So now the 9-volt battery looks like this, right? In this case, it acts, well, I'll make it big. Well, like a big resistor. How big? Almost, so, and now, okay, so now we can apply Ohm's law. Right, now we can apply Ohm's law here. Let me give specific values. I'm going to say, in this case, let's say it's 1 ohm. And in this case, we're going to say it's 1 mega ohm. Some people may say it's a short and it's an open, right? Like there's no connection at all. But I want to think of it this way. And let's say we put a 10 volt. We're going to make this a 10 volt source. So now the question is, how much current is flowing through in each case? Now, you'll notice I just changed the direction, right? Right? Because Ohm's law has a direction. And Ohm's law says that for a voltage in this polarity, the current is going to flow this way, right? Now, I could have put it the other way and said it's a negative current, all right? But this is the convention, right? And so in this case, the voltage is here, and so according to Ohm's law, right, and I'm sticking to Ohm's law, the current's going to go this way. In this case, we would say the current is equal to 10 volts divided by 1 ohm. So we're going to get 10 amps. It's a lot of current, actually, right? So there's a lot of current flowing in this direction. However, in this direction, I'm going to get 10 volts divided by 1 mega ohm, and that's going to give me 10 microamps, right? A million millionth. So when the 10 volts goes this way, a small amount maybe flows, a small amount, but a very small amount flows through. So you can think of a diode as a resistor that really cares about the direction of current flow. This is absolutely not the case with all the resistors we've used so far. With all the resistors we used so far, it didn't matter which way you stuck them into the circuit. There's no top or bottom to a resistor. A resistor here? Right, there's no top or bottom, right? The resistor is not, it doesn't come labeled with a polarity. The diode as an element, right, clearly does. It has a top and a bottom, and it's not going to behave the same way. But we can just think of it as that's a diode, right? Now, a light emitting diode is a diode where if a lot of current flows through it, I'm going to draw it here, it lights up. Right? So that's the light emitting part. Now, if I take a diode, here's my diode, and I put a 9-volt battery like this, it will light up because a lot of current flows through. But if I take the same 9-volt battery and I flip it this way and I touch it to the diode, it will not light up. All right? So that's a light-emitting diode, and it's perfectly okay to just think of it as big resistor, little resistor, depending on the direction. All right? All right? People will use a fancy term like nonlinear, but we don't have to go there yet. Okay? That's a diode. Except there's a problem. When too much current throws to it, so if you actually did this experiment, you took a 9-volt battery, you put a diode next to it, it would glow for 1 second, and then it would stop glowing. It would actually be destroyed. And the reason it is a problem, which is that if there's too much current flowing through the diode, it burns out. So we have, let's say we'll talk about a 9-volt. We have our 9-volt battery, and we have our diode, and it's a light-emitting diode, LED. And we would like to turn it on, like you want to make like a little flashlight or something like that, right? That's a great little instrument, right? A light source. But if you connect it, it immediately blows up because you are in this mode, right? Now, if you connect it the other way, and to be clear, we're going to do it this way. Now, if you connect it the other way, it's not going to glow at all because it's not going to pass resistance the other way, right? So you can't connect it this way because it won't glow. You can connect it this way. It's going to glow for a second, but too much. There's too much current flowing through here. How can we make it so that there's less current? Yes. We add a resistor, and that resistor is going to be in series. So we're going to take another resistor, and we're going to put it right here. And now the current is going to go like this. And let's call this R control for controlling it. Oh, interesting. But then how much? Right? How much should this be? And let's say I'm going to tell you that the goal, I want to even keep it simpler here. Let's go back to 10 volts. And the goal is to produce, the goal is to produce 10 milliamps, all right? 10 milliamps is enough for it to, this is for it to glow. It means glow, okay? If you get 10 milliamps through the LED, it's enough for it to glow, but it won't blow up. So it's a design problem. Now, this is 10 volts, this is given. This is the only parameter you can control in this design problem, right? So how do you pick it? Well, you have two things in series. Oh, resistors in series. Right? That's where we started today. See how I set up for it? Okay, I set up for it. These are resistors in series. And so this volt, I can combine these into one equivalent resistor. And you can say, but this is not a resistor. I'm saying I want you to treat it like a resistor for this purpose, right? So the equivalent, R equivalent, is going to be R control plus, and I'm just going to write here something small, right? I mean, it's a small contribution. And this is how you add resistors in series, right? Remember what I wanted to start with, what do we mean by equivalent? The equivalent from Ohm's law. The equivalent from how much current is actually going to flow here. And so the point is that the R equivalent is basically R control. It's like having a wire. It doesn't add anything. So the equivalent resistance here is actually just R control, right? So we can say that we can neglect this, right? If this is 10 ohms, then the overall equivalent is 10 ohms, right? And now we have all the information we need because we can say Ohm's law for the R equivalent. So Ohm's law says 10 volts is going to equal R equivalent, right, times, and our goal here is 10 milliamps, so I'm going to insert that here, 10 milliamps, but this is equal to R control times 10 milliamps. And therefore, R control is equal to 10 kiloohms. By putting 10 kiloohms here, you will have a situation where when you connect this, you will have 10 milliamps. And if you do this, your LED will turn on and it will not blow up. Now to be clear, I don't know if it's exactly this value, right? Maybe it's 1, maybe it's 20 milliamp, right? I don't think you want 100 milliamp through an LED. So now we have seen how we can extend the concept of Ohm's law and equivalent resistances to solve this problem. And that's where we're going to stop for today. Your next lab, by the way, is you have to turn on a light that corresponds to the temperature of the jar. So if the jar is 25 degrees, a red light has to go on. And if the jar is 30 degrees, a green light has to go on. Now that's a little bit interesting, but I've given you the first piece of this because I've shown you how to turn lights on. But now you have another question, how do I decide which light goes on? And that will cover next class with a circuit called a comparator.